Excellent. Well, thanks for the opportunity to speak here. I want to talk about something that we deal with every single day. Well, what we do at work is constantly fight problem solving with complexity. So I want to talk a little bit about complexity and how we could possibly make things a bit simple and to make things really manageable. So that's what I'm going to focus on today. Well, right here in this room, we have probably one of the most complex things ever, and that is our human brain. We are incredibly smart, we are innovative, but at the same time, we get tangled up with emotions. We don't really think clearly a lot of times. And then clarity eventually emerges out, but after a lot of struggle. So why do things get really so complex? What's really hurting us in terms of how we can do better? And in terms of that, a lot of times when I spend time with my children, we talk about various things, and oftentimes the conversation becomes, into science and physics, and we talk about Schrodinger's cat. Well, Schrodinger had this mental experiment. He said, what if a cat is sealed into this box, you cannot see through it, and he said that any given time the cat may be alive and dead at the same time. Well, it takes a lot of time to reason through things, and I feel like a lot of things in life are like the Schrodinger's cat. Well, when it comes to complexity we deal with, Confucius said, life is really simple, but we insist on making it really complicated. So I want to ask the question, why do we really make things complex? And I think I have a reason that we do. And the reason is, it feels really good. We have to be honest about it, isn't it? Well, if you build something and your colleagues look at it and they say, gosh, that's simple, you maybe feel a little let down. You say, let me come back tomorrow, reworking on this. And we want to give the impression that what we have done is important. And to do that, we often make things a little bit more cluttered and complex. Sometimes complexity sells. If things are simple, maybe we feel like it doesn't have any value. So we have to really fight the tendency quite a bit. Well, it turns out, Einstein actually said, any intelligent fool can make things bigger, more complex, and more violent. It takes a touch of genius and a lot of courage to move in the opposite direction. I want to underline a few words here that are extremely important. And that is a lot of courage. And that is what I think is one of the biggest challenges that we have to face. If you come up with something really simple, sometimes you get ridiculed about it. Sometimes we get critiqued by colleagues. And it actually takes a lot of courage to stand up and say, I don't need to make this really complex. Here is a simple solution to this problem that actually works. Why do we want to really make this more complex than it should be? To have that courage is extremely important. Well, if simple were sitting next to you in a train, would you even know that this is simple? And that is one of the things I often find as a challenge. I think almost every single developer you come across with would agree to the fact that we have to make things simple. So the problem is not that we are in disagreement about making things simple. The problem really is identifying what that simple really means. I remember working with a group of developers. I was constantly complaining that a particular piece of code was extremely complex. After about a few minutes of me complaining, one of the developers said, hey, Venkat, I just want to speak up for the group. You keep saying it's complex, but we collectively think this is simple. And I said, wow, how could you think this is simple when it's clear it's complex? Can you tell me why you think it is simple? And the developer said, yeah, because all we are doing in this code is use a very simple if-else statement. And that's when it dawned on me, a lot of us don't know what complexity really means. Well, I pointed out the problem is not that they used an if-else statement. The problem, the complexity came from that being repeated 70 times in this code. And that code being copied and pasted countless number of times throughout the application. Which means every time they had to extend the application, they had to spend a lot of time and effort changing every piece of code that made the decision, and the complexity grew from the violation of the right principle in this particular case. So we have to really ask the question, how do we really even recognize this and do it? Well, unfortunately, though, it's really hard to tell what simple is, as we have understood. Maybe I can take an opposite approach. Maybe I can try to say what is not simple, and maybe we can recognize that and avoid it. So let me take an attempt to that. So what is not simple? Well, simple is not clever. How many times have we written a clever piece of code? We all have done that, isn't it? But why do we create clever code? Because it feels like our solution is worthwhile when we make things really clever. And that becomes really problem after a while, after all. Well, let's take a look at this example here for a minute. Public abstract class enum, E extends enum E. Just think about that for a minute. Oh, that noise you just heard is your brain throwing an exception. That's when complexity kind of broods over things. And these are not very simple things for us to understand. We kind of stare at it and say, what does that mean really? Well, people often say, how do I obfuscate my code? And I often tell people, why do you want to obfuscate your code? Your programmers naturally write self-obfuscated code. Even they cannot understand it after a week of programming. So the point really is, we don't really need to really take the effort to obfuscate code. We want to really move in the opposite direction. Well, as it turns out, I came across this piece of code. Notice that float x. In all honesty, I don't have a clue what x means. But whatever x is, I've got good news for you. We now have half of it. And then, of course, don't tell me you don't understand this code, right? Because it's so beautifully done. And then when you read all this code, you're wondering, but I got some really good news with this code. At the end, it returns x. So the point really is, how do you really maintain code like this when all these become extremely cryptic for us to deal with? Oh, remember how we are told often that when we work with things, that the object-oriented programming models the real world. Well, we have to be very careful with those statements like this. One developer took it to the heart and wanted to really create an example of a program that modeled flights. And he created something along these lines. And my question is, where were the other developers while this guy was writing the code? Somebody should have said, dude, don't go there. Please don't do this to us, right? And that becomes really hard for us to maintain over time, and that becomes unbelievably complex for us to deal with. So complexity comes in several forms, but one of them is cleverness. We want to make things very clever, and we get trapped in the process after all. Well, the next thing I want to say is, simplicity is not necessarily familiar. We often confuse the word simple with the word familiar. Familiar is what we are used to. Familiar is something we have seen 1,000 times over and may not really care to see it again. And sometimes we have this comfort that we begin to feel what is familiar is actually simple, but the evidence is actually to the opposite. Well, let's think about this for a bit. If I ask you, what is this? Some people in the room may be able to answer. Other people are going to look at this and say, oh my gosh, that looks very complex. Well, it turns out this actually is not that complex at all. In fact, it is saying simple, uncomplicated, casual, and common. You may ask, how did I know it? I just used the translator. But the point really is that we often get confused with things that we are unfamiliar with. I travel around the world. I'm often in places where I don't speak the local language. It'll be pretty naive of me to turn around and say, everything around me is complex. It is just that I need to recognize everything around me is unfamiliar to me. I always keep asking this question to my developers. Is this something that's really complex? Or are you just telling me you are unfamiliar with it? One is easier to solve, the other one is really hard to solve. We don't want to deal with unnecessary complexity, but we have to remove the unfamiliarity about things quite often. Let's take a very simple example here just to get a feel for it. Let's say what I want to do is take all the values here, and I want to, let's say, total the double of even numbers in this collection. How would I do this? First of all, I'll say total equal to 0. Well, I want to, of course, output the value when I'm done with this, but what am I going to do in between? I'll say for int I equal to 0. And then what do? Then you say I less than, well, in this case, prices dot, well, if I take the prices value, what do I call after this? Is it length? Is it size? Is it count? We have to make a decision to that point. If it's an array, it's a length, otherwise it's a size. But then, of course, you stop and ask the question, is it less than or equal to? Do you ever ask that question? every single time. The only purpose of code like this is to make us feel really stupid. Because we get scared when you look at it. What if I make a wrong decision with this? And then to add complexity, we have to write that as well. Then what do? Then you, of course, have to say if. Again, to add insult to injury, you say get the element of that. And then I could say is mod2 is equal to 0. And then, of course, you can say total plus equal to maybe the price value. Look at all the complexity we get dragged into. Well, I call these as accidental complexity. And the reason I call these accidental complexity is this is not a complexity that came from the problem. It's a complexity that came from the solution we choose to use. And a lot of times, we get dragged into complexity like this. Make no mistake, a lot of us are very familiar with this style of programming. It is called the imperative style of programming. I grew up as a kid programming imperatively. What I'm trying to say in all those words is I had a terrible childhood. This was really complex things to deal with. But we don't have to deal with so much complexity after all. We could try to do this very differently. Let's give it a try, maybe slightly different way to do this. What if we started out by saying, in this particular example, let's start with prices as we did right now. But then we will say, given the prices, we'll go through an internal iterator. We will filter out. Given a price, I want to say price mod 2 is equal to 0, for example, then perform a map operation over here. And then in this case, of course, I'll say given a price, maybe I want to double the value over here, and then maybe I'll perform a sum operation in the very end of this to perform the result of that particular operation and compute it. Well, as you can see in here, I even forgot to double the value in the mess that I was creating. But the point really is, the code can become a lot more easier to understand, easier to follow. We can have a beautiful flow of the data through it. We call these the functional pipeline. Well, a lot of us are unfamiliar with the details of functional programming, but I took a long time to really figure out how to really use it. But once we become familiar with it, we begin to realize it's actually less complex compared to the imperative style of programming. So on one hand, what we are very familiar with turns out to be really complex. On the other hand, what we are not so familiar with may turn out to be actually simple in the long run. So the question to ask is, are we unfamiliar with things that are maybe simpler than, maybe familiar with things that actually are complex? So don't confuse familiarity with simplicity. So a lot of us are familiar with the imperative style of programming, but declarative is a lot more simpler. And so what does it really mean? Well, simple has fewer moving parts in it. And Michael Feathers once tweeted, I thought this was a brilliant way to express it. He said that in object-oriented programming, we encapsulate the moving parts. In functional programming, we eliminate the moving parts. That's a really brilliant way to think about it, because you want to eliminate that complexity rather than encapsulate it. Because when you encapsulate it, it's waiting to come back to bother you. When you get rid of it, it cannot trouble you anymore. Well, simple is not over-engineered. We come across solutions like this all the time. For example, well, Rube Goldberg made his name by creating very complex solutions for simple problems. Like, for example, coming up with this very complex automatic back scratcher. But if you really think about it, a lot of us have done this at work for our own projects. I remember working on a project where the developer had taken a data from a database and gone through 250 lines of code to transform it into XML. And then passes that down to another function. And that function parses the XML, performs a very small operation, and stick the data back into the database. I'm scratching my head. Why go from the data to XML and XML to data? And I called the developer and said, I'm looking at this code. And he said, isn't that cool? I was like, no. Why are we doing all this work here? He said, because this code is extensible. I said, extensible for what? He said, Venkat, you need to have a vision. I said, I'm really sorry, I don't get it. What vision am I lacking here? Where does the data come from? Here. Where does it go? Here. Then why are we going around the world to get the data back here? He said, no, you should understand the vision we should have in developing software. While he was saying it, I picked up the phone and dialed it. He said, excuse me, and I picked him, hello? He said, hello. He said, is that you, Venkat? I said, yes. Why are you calling me right when you're in front of me? I said, you need to have a vision. I could be anywhere in the world and talk to you now. So we should always talk on the phone, even if we're near to each other, right? Well, a lot of times we get kind of carried over by complexity and don't realize we got to really solve the problem we really have on our hands and not get carried away by it. Well, simple is not really terse. I want to write concise code, but I don't want to create a terse piece of code. For example, I came across this code on a client project. And I was doing a code review for them, and we were going over code, and we were trying to improve some design. And a developer showed this, brought up this file, and then quickly switched over to another piece of code. I said, oh, excuse me, can you go back to that code you just showed me? This was a code in production. And he said, sure. And I looked at it, I said, would you mind if I take a photo of that? He said, yeah, absolutely, go for it. As long as you promise never to tell who we are to the world. I promise. And I took a photo of it. Oh, sorry, what I wanted to take a photo was not this line, the line that was below this. This was in production. It said, God help me, I have no idea what this means. And developers write code like this. Can you imagine working on a project where? And I asked them, why didn't you remove these words? He said, that's the last word of the developer before he died, right, or quit. So there's a little respect to the person who wrote it. This is how we feel about it when we write code. Enormous complexity, not because the problem is complex, because we caused to it. These are called self-inflicted wound we create on ourselves. And so here's an example of a code where I'm using a very verbose test to write. I have a set price, and I have a max profit, and I have a fail, I have a catch. Gosh, it's a lot of code to write. We should do better than this. Well, it turns out this is a verbosity. How do we make it really concise? I would argue this solution from JUnit 3 and 4 is a terrible idea. And the reason it's a terrible idea is, notice that while this says I want this exception, it doesn't tell you which line actually caused the exception. I never want a test to pass rather, for the wrong reason. And I would argue this is not a concise code, it's a terse piece of code. So what is the difference between terse and concise? Both terse and concise are really small, but terse is waiting to hurt you when you least expect it. So I want the code to be concise and not terse. So I would rather rewrite it using lambdas. This is what JUnit 5 provides for you in concept, that is. And so here you can wrap that code in a lambda expression and say, I want that piece of code to fail, not anything else. And this is concise and communicating the intent very clearly, as you can see. So we don't want the code to be terse after all. So don't confuse terseness with concise and simple as well. Well, here's a beautiful quote by Tony Herr. He says, there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies. And the other is to make it so complicated that there are no obvious deficiencies. And we deal with this a lot of times. We don't even know what's broken in a piece of code. I remember working on a project. As I was going through the code, I found there was one variable totally unprotected from concurrent access. I went to the team and I said, excuse me, I'm looking at this variable. It's totally unprotected. Are we not going to have concurrency issues with it? And the minute I said this, one of the developers got very angry and said, hey, Venkat, this code has been in production for 3 years. What makes you think you can come and scare us today? I didn't know how to answer that question, but thankfully I didn't have to. Before I could say anything, one of the other developers said, aha, but wait a minute. Remember how our code crashes every 2 weeks and we have no clue why it does. So sometimes we kind of deal with issues, don't even know what the problem could be potentially. Well, okay, so I talked about a few things that are signs of not being simple. But it's only fair that we talk about what is simple, though. We said simple is not clever, simple is not necessarily familiar, simple is not terse, simple is not over-engineered. But okay, this is all what it is not. But how about talking a little bit about what it might be? Well, let's take an effort. Simple keeps you focused. What is the most valuable thing in the world today? In the world we live in with tweets and Facebook feeds and everything around us to constantly distract us, I think it is our attention. If a code can keep us at our attention, that is wonderful. If a code is not keeping our attention, we move away to do other things, and the problem is still at hand, and the solution is still away from us. So we want to really help to keep things focused. Let's talk about this a little bit. Let's say for a minute, you and I are programming, and we're not quite sure what Java API to use, and we're not even sure how we would approach a problem. What do we do in this today's world? You don't get paid to take 7 days to solve a problem that every other person has solved already. So you might tell me, Venkat, why don't you just quickly do a search? Fair enough. Why don't we do a quick search to find out the solution to our problem? Well, I'm going to go ahead and bring up the browser to do a search right away. And the minute I go here, hey, interesting, what does it say here? Oh, look at that. There's some really interesting news up here about various things happening. Even about Los Angeles here. They're talking about some brilliant company. Well, you know where I'm going with this. The minute I went there, I got completely hijacked with these stories. And 20 minutes later, I'm like, what am I trying to solve again? And I completely got hijacked with the process. This to me is unbelievable amount of distraction that's out there. What I came here for is that little box. But what I got distracted about is all these wonderful things that are sure interesting things, no doubt about it. Let's try this one more time, if you will. So let's go ahead and quit that. Hey, let's do a search over here. What a beautiful picture over there. I am not sure what that picture is. I want to search for it, but I'm a little anxious about it. What if I recursively end up with yet another cute picture? 20 minutes later, what was I trying to do a search? Let me try this one more time. Let's try this again. I'm going to search. What can I do at this point? Search. There is not a whole lot else I can do. How many of us use Google here? There's a reason for it, right? Because you care about your time. And I want you to think about this for a minute. Just close your eyes and imagine this. Let's not get convinced this is easy. Remember what Einstein said, it takes a touch of genius and a lot of courage. Can you imagine the day when this developer went to his boss and said, I've got the search page working. Let's see it. Here you go. And the boss said, what the heck is this? Well, it's a search page. I see it. What? There's nothing here. Well, I put a button called I feel lucky. Well, you should. Do you think how many of us work in companies where you can present that kind of simplicity and get away with it? Very difficult, isn't it? Because the minute you present something, people say, show me something more. I want something here. This is too simple. But the simplicity is the genius here. Let's make no mistake. The minute you click on that button, even if before you click on that button, there is enormous amount of complexity behind that button. Several servers and algorithms and data structures and processors are running behind it. But they didn't bring that complexity to us and say, you suffer with it. We don't have to be distracted. Simplicity is the essence. This is one of the reasons why I love pair programming, honestly. Why? If I'm sitting alone, there's a beautiful statement called shaving the yak. Shaving the yak simply means you're not solving the problem you're working on, you're solving a meta problem. We all do that. That is in us. If you're not shaving yak, you're not a developer. We all just shave yaks, just don't talk about it. And if I'm alone and programming, I bring up the browser, and the browser says, would you like to upgrade? Oh, yes, of course, click on it. Next thing, you get a proxy error. 20 minutes later, you're fighting something deep down here, and the boss comes to the closet, opens the closet, and says, excuse me, what are you doing here in the closet? Oh, I wanted to search for this Java API. I turned on the browser. It told me, do you want to install the upgrade? I clicked on the button, got a proxy error, and everything is vague after this. And suddenly, I don't know why I'm in the closet shaving the yak right now. And this we get dragged into quite often. Well, let's say you're pair programming, you're sitting next to somebody, and you're coding with them, and your colleague says, why don't you just search for it? You bring the browser. It says, would you like to upgrade? And the colleague says, and it's like, oh, never mind, not now. So many yaks are being shaved for that afternoon, isn't it? The point really is it keeps our focus to do what we want to do rather than getting dragged into something we shouldn't be focusing on at the moment. So the point really is perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. What a beautiful quote. I try to remind myself of this every single day. It is not what I can add, but what I can remove that really makes things simple. This is, to me, the key behind refactoring. I refactor a piece of code not to add stuff, but to remove the clutter. How can I make this piece of code continue to work when it can have fewer elements in it, when it can have fewer things in it, and still it can serve the need it does to remove all that complexity that is in front of me to make it really simple? Well, simple eliminates accidental complexity and hides inherent complexity. So we are dealing with complexity, two types of complexity. One is inherent to the problem, the other is accidental to what we do. And simple fails a lot less. If I ask you the question, why is this cover circle in shape? I think most of us would give us the reason immediately. And the reason is, it doesn't fall in. Well, here's the question to ask. Yes, it doesn't, well, if it doesn't fall in, that's great. That's a good answer. I'm not saying it's not. But if I came to you with a request to create something that doesn't fall in, how many of us will create it? Especially if you're a consultant getting paid by the complexity that you create. I'm one of them. How would you really create this? It turns out, here are the solutions that also qualify for that. And we would have made more money creating one of these shapes, and all of them qualify, they don't fall in. Well, it turns out there is yet another important benefit of this design. Not just it doesn't fall in, it doesn't matter how you roll that on that. Imagine you are the dude who is coming out of it. And then at the end of the very long day, you're trying to put the lid on while your colleagues are waiting. Hey, what are you doing? Trying to see how to fit this in. Just roll the damn thing over, let's go home, is a beautiful solution to have. So the point really is, it is not just it doesn't fall in, but it is very easy to use. It's intuitive and it fails less. And that is something we need to really keep in mind. As an example, though it's been quite a while, long time ago, I remember this weird experience when my child was very small. In the middle of the night, your wife wakes you up and says, could you please go get the bottle for the kid? And you're about absolutely half asleep. Your eyes could barely be open. And your problem at that point is to fit the bottle with the lid. I remember this saying, this sounds like an NP hard problem to me right now, right? Trying to fit that in. That is complexity you have to deal with, which is completely unnecessary. And we see this in every aspect of life when things become incredibly hard to do. So simple is easier to understand and easier to work with. That is a nature of simplicity as well. So here's an example. Let's say I want to find if a number is a prime number. What if I can do something like this? Is prime and return number is greater than 1 and a stream of data where I can say none match and find if a number is prime. What if I can find all prime numbers? Well, what if I do something like this? Prime given starting at, if the number is prime, return that concatenated with everything following it, otherwise skip it and return everything following it. Ideally, this would be great, but it doesn't work. Why not? Because this leads to what's called an infinite recursion, and it blows up eventually. Great idea, but hard to implement. Or maybe we can try this a little differently. What if we can write something like this, stream.iterate, and we can keep generating this lazily, and then we can limit to the number of values we create. Well, solutions which are unfamiliar becomes enormously beautiful to use once we figure out a way to actually do it. And that becomes a very compelling way to organize it. Let me explain how this really helps what we do. Well, simple is very elegant. And, well, what about elegance really means? Well, we need to really appreciate elegance in quite a different number of ways to it. Why is this the world's famous painting ever? Well, the reason for that really is that if you look at this picture, it is the most simple thing you could even ever imagine. There is not a whole lot here. There is no clutter. There's no ornaments. There's nothing to distract. This is pure genius, as we call it. And the man is genius not because he created something complex. The man is a genius because he created something beautiful, elegant, and simple. That's why we admire this. I'm going to talk about what's called an architect's dilemma. I was in Boston, and I was walking through downtown Boston with my family. We were having a good time enjoying the city, and I came across one thing that just absolutely mesmerized me. And this is the Trinity Church. I stood admiring the church until my family said, "Dad, we have to move now, or we're calling the cops on you." And what was a thing that admired me? It's just like any other church, isn't it? Oh, this is not the church I was admiring. What I was admiring is something very nearby. Where next to the church, there is a building called Jan Hancock Building. And when they wanted to construct this building, the city would not give permission to build it. And they said, "We won't let you build it here because if you build the tall building here, the beauty of this historic church will go down, so no." And the architect of this building said, "I'll take this challenge. When I finish this building, the church will only look more beautiful than it does now without ever touching it." So what did he actually do? He built the building in a particular angle with beautiful glass doors. And my camera is not doing a justice to this, but I stood there admiring the reflection of the church on these glasses, telling myself and everybody else around me saying, "Isn't that a stroke of genius right there?" In the ability to really reflect the church so beautifully that you could just admire the church, not directly, but through the reflection. And this again is very simple solution to a problem at hand. A lot of us cannot even think about it. And we're trying to fight the solution when we can innovate simplicity through it. But it turns out simple has to evolve. Let's make no mistake, we cannot sit down and create something simple. Nobody can, in my opinion. We kind of create simple by evolving from various things we do. We have to take the time to evolve it. Richard Feynman said, if you cannot explain something to a first-year student, you haven't really understood it. This happens a lot. In my own experience, I've seen this quite often when I try to teach a course or write a book about a certain concept. I find it incredibly hard to explain, and at that point I step back and say, I know why it's hard to explain, because I created a monster. I have to simplify this before I even try to explain it. But Occam's razor says if you have two equally likable solutions to a problem, choose the simplest of it. I'll share with you a personal experience about it. I was writing the book on Java 8. This was about a year to 2 years before Java 8 was released. And I was very eager to write this book on Java 8 to sing its praises, but I also wanted to show some things in the book which are really hard to do in Java, but you could really do with functional programming in Java. Well, I've read some things before to prompt me to do this. Here is an example of a factorial, and I can say if number is 1, return the number, otherwise number times factorial minus 1. Well, clearly no, this leads to a stack overflow error because of an infinite recursion when the number is very, very large. How do we really solve this problem? Well, here's an idea. I've read through some interesting books and worked with some languages. One of my favorite books is Structured and Interpretation of Computer Programs. In this book, Sussman and Abelson talk about two different things. They talk about procedure. Procedure is what you write. They talk about process. Process is the code that runs after compiling, transformation, stuff like that. If you write an iterative procedure, it runs as an iterative process. If you write a recursive procedure, it runs as a recursive process. But the real power is, if you can write a recursive procedure, but in turn it runs as an iterative process, that is when we can get the elegance of the code and the performance at the same time. So this kind of optimization is done by several compilers, Lisp being one of them, Erlang being another, Haskell being the third one. A lot of functional programming languages do this. Scala does this at the compiler level. So does Clojure. Groovy does this at the library level. So when I sat down with Java 8, I said to myself, aha, These languages do this in so many ways. I know language like Groovy does this at the library level, Scala does it at the compiler level. What if I can implement tail call optimization in Java? So in the middle of writing this book, I started playing with tail call optimization. Not a good thing to do when you're writing a book. I spent about 2 days of my life doing nothing, trying to implement tail call optimization. And here's what I came up with. Further, 10 hours later, I came up with this solution. While not complete, current equals current.apply, call complete is equal to current.isComplete. Just focus on this while loop. Well, the problem is this. In the book, until the previous chapter, I repeatedly told the programmers, avoid mutability. And here I am with a beautiful solution to a complex problem, which is doing mutability. And I was stuck, honestly. And I sat there, stared at it for a day. I could not know of a way to remove this loop and the mutability in it. And I think I came up with a brilliant solution to the problem, and I hope you will agree too. What I did was, I wrote this in the book and I said, dear reader, do you see that I'm using mutability on this line number 7? The challenge to convert this code to immutability is left as an exercise to the reader. I thought this was a really good solution, honestly. This would have worked 30 years ago when we didn't have the internet, because I can hide comfortably after writing a book. Today we're on social media. The minute this goes to print, somebody will tweet and say, oh yeah, why don't you take the challenge yourself and show me how? That's not going to work. Then I rephrased it. I said, dear reader, do you see me using mutability here? Don't use mutability in every place you can avoid it, except places like this. And that really felt sick. And I realized my code just sucks. I got to do something different. And honestly, I said, I don't understand this. Maybe I will run into one of my Java friends, show them the code and say, what do you think? Is there a better solution? I said, I'll wait for that. Then a couple of days went by. I moved on to write other chapters. And then I was on the treadmill jogging. As I was jogging on the treadmill, my mind completely detached from the problem. Slowly, I started thinking about it. And suddenly, it dawned on me. I'm like, oh my gosh, I've been looking at this problem wrong. There's a much simpler solution. I never even thought of it. I jumped out of the treadmill and ran across the floors of my home with my children screaming, are you okay, Daddy? I'm like, no, you don't understand. I got this problem figured out. 10 minutes later, I had the code working. So what did I do? Well, here's what I found out. I can turn the recursion problem into an infinite stream problem. Just think about this for a minute. What if I take every single function call, think of it as an object for a minute. Then every function call is an object. Then this object can form in a collection. It can form in an infinite collection. Well, all of a sudden, when I finish a recursion, I say, give me the next recursion. Give me the next recursion. And I keep getting the next recursive object to execute. And the minute I realized it, the solution is gone from complexity to something simple with no mutability. Stream.iterate the current call and apply to get the next call. Keep going until the problem is complete. Find the first one. Get me the result of it. This is what went into the book eventually. Well, what is cool about this, though, is it is a lazy evaluation and an infinite sequence. It becomes incredibly easy once we understand how to do these functional mapping. So a lot of times we struggle with solutions, maybe for days, maybe for even weeks. Sometimes the best time we find solution is when we are away from the computer, when we are away from the problem we are dealing with. Our mind detaches, and suddenly there's a click. And if somebody comes to you and says, how did you figure this out? The normal answer for that is a shrug. I don't know, I just thought of it. And maybe I say something, you say something, I say something, and you say something. I'm like, oh, wait, that's brilliant answer. And you're like, what did I say? No, look at the solution. We come up with solutions that way, which is fantastic. Well, Einstein said, everything should be made as simple as possible, but not simpler. So I always wonder, is my solution simple, or maybe is it complex? I might think it is simple right now. you might look at it and say, why are you doing this? Here's an alternative solution which is much simpler. And I'm like, yeah, what you suggested is much simpler than I thought about. Let's go with it. And this is a discovery that keeps happening almost every single day. It is not about my solution versus your solution, by the way. It is about working together to find a simpler answer. And sometimes you may have a better answer, sometimes I may have it, or sometimes both of us will come together and realize a better solution in the end. So we have to work continuously towards it. So is this simple, or can it be simpler than this? I'm going to say simplicity is like Schrodinger's cat. The solution we come up with is simple and complex at the very same time. It is simpler than what we had before. Maybe it's more complex than what we will do moving forward. Simple makes things easy, but let's not make mistake. Simple is not easy at all to create. It takes a lot of effort to make things really simple. As Da Vinci said, well, simplicity is the ultimate sophistication in life. And every bit of effort we put in to achieve that simplicity, in my opinion, is worth it for two reasons. We make the current problem at hand simpler. We also gain the skills we need to address complexity. I would say the very first thing we should do, really, is to even have the sense of complexity. A lot of times we go through for weeks and months sometimes and not even realize that we are sitting in front of something highly complex than we should really. So the very first step is to develop that sense. And the second is to tirelessly work towards making things simple. And eventually, not only we make things simple, we also develop the skills to make things simple also in the long run. And I think that's pretty worth it for what we do. Hope that was useful. Glad to take any questions you may have. Thank you. We got about 2 minutes. Delighted to answer any questions or comments you may have. Please don't hesitate. Thank you.
Wait for the mic, please.
Hey there. Thank you for your talk. That was super informative, and I'm in web development, so there's not a whole lot that I can wrap my head around, but I was able to keep up because the points you were driving home were really universal to all coding and all programming. So I appreciate that. Thank you for just diluting it down so everyone can understand.
Thank you.
As a new programmer getting involved, where do you think would be a good path to begin?
That's a really important question, and I'm not saying this lightly. One of the things I think we should really take the time as developers, whether you're senior or junior, is to really implement a fairly decent feedback loops. I have gained so much knowledge, not because I'm smart. It's because there were kind people around me who would look at what I did and said, you can do better. Sometimes people say, what if I'm wrong? I want to emphasize you're never wrong. You've just done something that could be improved. That's the way to look at it. So ask other people around you to review what you do. Ask them to critique you. Ask them to give feedback. And knowledge is a wealth that grows when it's given. Not only do you gain, I bet you they gain as well, because when they look at what you have done, they begin to think and realize there are better ways to do. And one of the things I admire at young people today is they pick up so many things that I may not have time to pick up. So in the process, we both really become better. So I cannot emphasize enough, a review mechanism is extremely important. We're not just doing it enough in our industry. We should do that. Feedback loops are an incredibly powerful way to do this.
Absolutely. Thank you.
Thank you.
Appreciate it.
Absolutely. Thank you.
Good morning, sir. Just a quick question. Premature optimization is a well-known issue. So I never come up with a simple solution at the first. So what do you use to define if it's already time to optimize or simplify versus that you have to perfect the solution yet, probably dealing with more complex issues?
Right, so that's a really important question to ask. When do we begin to optimize? My recommendation is when it is complex, keep cleaning it up to make it simple. However, to me, optimization has to be driven by a result, not by a goal to optimize. I think that's where a lot of us fail. We want to optimize the code, and I always ask people, what are you expecting as a result after your optimization? Oh, I want to improve the performance. Can you tell me what your current performance is? I don't know, but this has to be fast, is not a good answer. So set a goal, A, and second, see how your code performs to that goal right now. Third, ensure that goal is really a true goal. I can optimize endlessly on a piece of code. If that has zero value for the business, I wasted my company's time and my effort towards that optimization that has no consequence. So is the result relevant to the business? And finally, the question is, how do we optimize given all these tests that pass? Is the time to really look at it? So a very important question. I'm glad you asked that. But we need to answer so many questions before we can even sit down to optimize. And a lot of times it's a foregone conclusion. We begin to optimize even without considering it. And I think that's a bit of a disservice. I think that brings us to the end. I'm out of time, but I'll be hanging around today. So if you have any questions, I'll be more than happy to talk to you along the way. Thank you for coming.